My name is Mandar Mitra. I teach at the Indian Statistical Institute. I am really a computer scientist rather than a statistician, but I believe this session is intended mostly for statisticians. I will try to do justice to the subject. So, the topic for today is text analytics. What we will try to cover in the next 30 minutes or so is I will try and give you an overall feel for what the subject is. Let us start with attempting to define what text analytics is. So, maybe we could describe it as something like the science of extracting potentially useful information from unstructured textual data sets. Now, as with any definition, this conveys a meaning to you only if you already know what text analytics is. So, maybe the next thing I will do is give you certain concrete practical tasks that text analytics tries to address. Also, I think in this connection it might be useful to mention certain other topics or other keywords that the viewers might encounter in connection with text analytics. Other topics that you might hear in this connection are things like information retrieval, natural language processing, and most likely text mining or text data mining. And if you look up other sources, what you will probably find is that the definition that I have given over here is actually a definition of text data mining. Indeed, if you look at Wikipedia, then the page for text analytics actually redirects to the page for text mining. I think it would be fair to say that in many ways text mining or text analytics is something like old wine in a new bottle. So, the older more traditional disciplines that have given considerable inputs to the area of text analytics are things like artificial intelligence, machine learning, pattern recognition, and of course, the parent of all these subjects, statistics. So, to move on to, as I said, concrete examples of tasks that text analytics tries to address, let us start with the simplest, something that we do all the time. Searching on the web is something that all of us do as a almost daily activity. I mean, the formal term for that is information retrieval, and the task of kind of finding useful information in connection with an information need is basically what information retrieval is all about. And one might argue that information retrieval is probably not text analytics per se, but I think the techniques used in text analytics borrow heavily from the techniques used in information retrieval. So, what we will start with are the basics of IR, and that is information retrieval, and those are also, as I just explained, the basics of text analytics as well. Other tasks that I think people would agree more readily that they fall within the purview of text analytics is text categorization. So, that is formally the task of classifying documents into certain predefined categories, and text clustering, which is similar, and I will explain the difference later between what text categorization and text clustering is. But for the time being, text clustering refers to creating groups of documents that are related to the same subject. The three things I have listed here are all traditional tasks in that they have been studied for very many years, and they are relatively well understood. If you look at some of the excitement surrounding text analytics, you will probably also encounter certain other tasks, and as I said, I mean, in the space of 30 minutes I will not have the time to cover all of these, but just to give you an idea of what is involved for completeness. So, you also have something like sentiment analysis, which deals with looking at textual documents and trying to identify what opinion or what affective state the user is trying to convey through the document that he or she has written. A different task that is also very useful is something called document summarization, where the system tries to take a large number of usually long documents and produces a more concise, easy to consume form of those documents. One additional task that I think belongs within the purview of text analytics and that has attracted a good deal of attention in recent times is the task of entity extraction, entity disambiguation, and trying to determine relationships between entities. So, I think that is best explained using an example. think of a name like Michael Jordan. Now, depending on what your background is, Michael Jordan may mean different things to different people. So, from somebody with a statistics or a machine learning background, Michael Jordan would refer to a very famous scientist. For somebody who is more interested in the sports world, Michael Jordan would refer to a basketball player. So, the task of entity extraction is first to identify that Michael Jordan refers to an entity, in this case it is the name of a person. Next, disambiguation means given a particular context, figuring out whether the mention of Michael Jordan refers to Michael Jordan the basketball player or whether it refers to Michael Jordan the scientist. Indeed, there could be other Michael Jordans as well whose existence I am not aware of, but that is what entity disambiguation refers to. And finally, entity relation modeling is kind of one step ahead from that, and it would try to kind of connect say Michael Jordan the basketball player with say Magic Johnson another basketball player as being people who kind of belong to the same sport. So, as I said, these last three, while they are exciting, they are still I think very active research topics, and for want of time we will not really go into the details of those three. We will spend most of the time talking about traditional information retrieval, text categorization and text clustering. So, the first thing that we need to do is think of what comes to mind when you are talking about natural language text. It is basically an unstructured form of information. What do I mean by unstructured? Think of it in contrast with say tables of data. So, in tables you know that the columns are marked, the entries in each column your kind of the table headings tell you what the entries in each column means, and maybe there is a caption that explains the relationship between the different columns of the table. Unstructured text, as the name suggests, is kind of just running natural language text. So, in order to kind of convert this into a form that is convenient for processing using a computer, the first thing we need to come up with is some means of converting unstructured text to a structured representation. So, this task of conversion is in traditional terms referred to as indexing. The whole idea is given any document, and maybe it is a good idea to point out that by document I mean any piece of text. So, it could be a formal document in the sense of what you see as a PDF file, it could be something as short as say a Twitter post. It could be something in between like say a review that you post to Amazon or any of the other say e-commerce sites, or indeed any of the movie sites like IMDb. So, any piece of text that forms in some sense a unit is what I will refer to as a document in the rest of this session. So, coming back to the task of indexing, indexing basically means representing any document via a set of keywords. So, this idea, notice that it is something that we are all familiar with, and it is an idea that has been in existence for I would say maybe 50 plus years. Probably, or one of the most familiar examples that you would see of characterizing a document's subject matter via keywords is think of books in a library or think of journal articles. Usually these will have definite subject descriptors which give you a very high level view of what the book or the journal article is about. If you think back to the kind of document I was referring to, namely a document kind of spans the range from formal documents to something as small as Twitter posts, you no longer have the luxury of kind of thinking carefully and assigning a set of keywords to any document. So, what we necessarily need to do is, given a document, we have to formulate completely automatic methods for assigning to that document a set of subject descriptors that will convey to anybody a sense of what the document is about. So, this is the well known bag of words representation, which is that a document is represented by a list of content descriptors, and I will use the terms keyword, indeed word, content descriptor or term interchangeably. So, if we do not have access to subject experts to and assign keywords to a particular document, what do we do? So, what we do is we look at the words contained in the document itself. So, here is a little snippet, and if I remember correctly, this is taken from the definition of information retrieval as given in Wikipedia. So, we start by simply constructing, I mean, given any piece of running text like that, we start by constructing a list of the words contained in that text. So, for this particular passage, you would get a list of separate words like information retrieval, IR is the, and so forth. And this step of identifying the individual words contained in any passage is called tokenization. So, the whole idea is that we will select some of these words as the content descriptors or keywords to be assigned to this particular document. Now, clearly you can see from this example that words like is, the and of would appear in any document that is written in English, and they are not really telling you anything about the subject matter of the document. I mean, anything that, I mean, you could talk about say a cricket match and you would still be using words like is, the and of. So, these are the so called stop words or function words, and since they are clearly not indicative of the subject matter of the document, the first thing we do is we look up traditionally pre-constructed lists of stop words and eliminate words such as is, the and of from subsequent processing. The next thing we want to do is we want to do some kind of term normalization, and by normalization what I mean here is, if you look at this example, resignation, resigned, resigns, all of them really deal with the same basic idea. It is just that these are different parts of speech, or to use a more technical term, they are inflected forms of the same basic root form. So, what we are trying to do as part of this indexing or keyword generation process is to reduce all of these to some kind of a canonical representation, and this process is called stemming. And for languages like English or other well studied languages, there are standard algorithms which essentially make use of knowledge about the English grammar to given a word to reduce it to its root form. For languages that are not as well studied as English, say, we have to take recourse to statistical means. So, that essentially deals with things like word counting, but again, I mean, I will not go into the details. Hopefully, some of the additional reading will give you further references to what some of these statistical stemming algorithms might look like. Additionally, I think if you are trying to characterize the content of a document, think of a document that talks about pollution due to say automobile exhausts. Somebody else might be thinking about the same subject, but instead of the words automobile and exhaust, they might be using words like vehicle and emission. Now, what we would ideally like is to kind of characterize each document by a sufficiently comprehensive keyword that would kind of, irrespective of whether a particular consumer is thinking of that concept in terms of vehicles or automobiles, the representation should work for that consumer. So, it seems like a good idea to use a thesaurus to add in related terms related to the terms already found in the document. So, here are a couple of links to online thesauri that have been extensively used in the text analytics field, but the idea, as with many other ideas, is kind of harder to implement in practice, even though it sounds fairly intuitively appealing. So, kind of for completeness sake, I will mention the possibility of using thesauri, but I will not go into the details of how it is actually used. So far we have confined our attention to kind of implicitly to single words, but I mean if you think for a moment, you realize that many of the keywords that we use all the time are really multi-word entities, in the sense that things like artificial intelligence, text mining, these are really not single words. I mean, they are word pairs that work very well as keywords. So, in addition to single words, it is also useful to find word pairs or word triplets like the examples shown here, which convey in a very specific way the subject matter of a particular document. Again, I will not go into the details of how these are found, except to tell you that there are kind of both syntactically or linguistically motivated methods as well as methods that are statistical in flavor, which is to say that they are guided mostly by counting based arguments. Finally, I have also talked about entities. So, usually any document that talks about entity, it is also useful to assign to it keywords that correspond to those entities. So, at the end of it, what we have is a document goes through this process of tokenization, which remember is a kind of making a list of all the words in the document. You filter out the stop words, you stem the remaining words, and you possibly make use of these additional optional steps, and you get to a bag of words representation of the document. So, the first simplest task that we might address using this bag of words representation is the elementary task of searching for useful documents in response to a particular query. So, what I will do is I will talk about one particular model for representing documents that apart from or in addition to the bag of words representation that we have talked about, does something else. So, here is what we are talking about. We have already seen that a document is converted to a list of keywords or terms. What the vector space model does in order to facilitate searching or retrieval is, along with the keywords assigned to a particular document, for each keyword it also computes some kind of a numerical value that we refer to as the weight. What is this weight intended to signify? It is essentially some measure of how strongly or how well a particular keyword represents the content of a document. So, now if you are dealing with a set of documents D1 through Dn, we could actually represent the document collection by a matrix in this form. So, the impression or the idea I am trying to convey is that documents D1 through Dn correspond to the rows of the matrix. Each column of the matrix corresponds to a distinct term, and T1, T2 all the way up to Tm together comprise the set of all distinct words contained in this collection. So, the usual term that we use to refer to this set of distinct terms in a collection is the vocabulary of that collection. So, now as I said, each row represents a document, each column represents a term, and the entry, the ijth entry in this matrix will tell you, or it will be a certain number that conveys how strongly term Tj is related to the content of document Di. Of course, if a term is not contained in a document, that weight is usually 0, which conveys that the term is not related to the document at all. So far what we have discussed tells you how to obtain the bag of words representation, which is given a particular Di, which Ti's you would assign to that particular Di. What about computing the weights? So, here are some, I think kind of there are multiple ways that we can compute the weights assigned to a particular term within a document, but for convenience I think I will just look at certain heuristics that are used to compute these weights, and they are fairly intuitive. So, here is the first quantity that you might look at in order to compute the weight of a term in a document. It is the so called term frequency. What is the term frequency? That is essentially a count of how many times a particular word occurs within a document. The idea being that if a particular word occurs frequently in a document, it is probably more strongly related to the subject matter of the document than something that occurs less frequently. Now, if you think about this idea for a bit, it should be possible to come up with some kind of a counter example, which is best explained I think using an example. So, think of a document collection in which all the documents pertain to say the records of the medical records of patients in a hospital. So, each document would contain things like the patient's name, age, gender, particular medical condition, what treatment was prescribed, how the patient responded and so forth. Now, the terms patient, medicine, treatment, if you look across the collection, these terms are likely to occur in almost all documents, and therefore, while they do convey some information about what the document subject is, they are not really for this particular collection very discriminatory, in the sense that consider a doctor who is looking for treatment of hypertension. Now, the words medicine or treatment, they are going to occur in, as I said, in almost all documents. So, they are really not going to help the doctor distinguish between patient records that relate to hypertension and those that relate to other medical conditions. In addition to the count of the number of times a word occurs within a document, we also need some notion of the word's specificity, which is kind of usually conveyed by looking at how many documents across a collection that particular term occurs in. So, going back to the example we were discussing earlier, a term like hypertension would occur in a relatively small number of documents, which is to say its document frequency would be low, whereas a term like patient or medicine would have a high document frequency in the sense that it would occur in many documents. So, some combination of term frequency and what I have just been describing, which is inverse document frequency, is used to compute the term weight that we discussed earlier and used to kind of fill in the term document matrix that I showed earlier. So, this representation is really the basic representation that is used in all the three elementary tasks that I mentioned in the introduction, which is to say search or retrieval, text categorization and text classification, text clustering. So, what I will try to do in the remaining time is to give you a quick idea about how this representation is used to address each of these three tasks. So, first the task of document retrieval. Remember, we are representing each document D as a list of numbers, where Di represents the importance of T1 in document D. If we have a similar representation for Q, the query provided by the user, with the exception that notice that Q will typically be much shorter. Think of most of the web search queries you enter, they are usually not more than 2 or 3 words long, which means that most of the numbers here will be 0 and you will have a small number of non-zero Qi values. So, what we do is, given that each document is a row and given that each query also looks like a row, what we do is we simply compute the inner product between the query vector and the document vector. So, now notice that formulating the similarity between queries and documents as this inner product has the desirable property that this sum will be high if you have multiple matches. This sum will also be high if the matches are on important terms, where the importance is conveyed by the weight of a term within a document. So, again kind of the overview of the retrieval task is, given a query, you compute the similarity between the query and all the documents in the collection and rank the documents in decreasing order of the similarity score. The expectation being that the documents that most match the user provided keywords will come up at the top of the ranking. For reasons of efficiency, this is actually not implemented the way I have described. It is implemented using what is called an inverted list or an inverted index, which we will skip for now. So, that is kind of an overview of retrieval. Let me quickly skip to the basics of how text categorization might be done. So, recall that text categorization is basically you take a collection of documents, you also have a set of predefined labels, and for each document you have to determine what is the most appropriate label for that document. Notice that in this case the labels are broader than the keywords, in the sense, or kind of, if you consider as an example, say you have a collection of books borrowed from a library and you want to classify them into subjects such as statistics, computer science, philosophy and so forth. So, that is basically the kind of task that categorization tries to address. So, the notation that I will be using in the couple of slides that we have on text categorization is, I will be using D1, D2 through DM to refer to the documents, and the categories are capital C1 through capital CL. So, as with many other problems, there are very many solutions, different solutions to tackle this one as well, but for a audience that is primarily interested in statistics, perhaps the naive Bayes approach has a particular appeal. So, here the idea is what we are trying to do is, given a particular document dj, we are trying to predict what category is most appropriate for that document. So, you use Bayes theorem and you can rewrite it as this. Now, notice that if you look at this quantity, what we have is some probability that C I is the appropriate category for document dj. Now, in order to decide which category is the most appropriate, we are really doing some kind of an ordering, which means that since the denominator is the same for all categories, we do not really need to keep that denominator around. So, simplifying it to an expression that will give the same kind of ordering, we come to this. And really the important part, I mean the Bayes theorem part, I am sure you are all familiar with. Where does the naivety come in? And the naivety comes in from when you determine what the probability of obtaining dj from category Ci is, we actually go back to our representation of dj as a set of keywords. The keywords are regarded as independent. So, you get this simply as the probability of dj is regarded as a collection of probability of collection of words, and that is simply the product of obtaining the individual words from the category as a whole. For just a quick overview about clustering, it is very similar to what we have talked about in text categorization, except the principal difference is that the categories are not predefined. We have a natural kind of what we want is we have a collection of documents and we want to find the different subjects that are there without having a preconceived notion of what those subjects might be. Once again, we fall back to our vector space representation of the documents, and what we could do is something like use the so called k-means algorithm. So, here the idea is we kind of randomly select a set of documents as prospective cluster seeds and then assign other documents to the cluster that is nearest to it, and then we recompute the cluster seeds and we keep doing this process until we have so called convergence. So, there are a number of different issues in connection with k-means or k-medoids clustering, which we will not have time to go into. So, I think what I will do at this point is jump to a set of references that you can use for further exploration in this area. So, here are some overview papers that I think would give you a fairly comprehensive idea about what text categorization and text clustering are, and for completeness I have also included certain articles that give a good treatment of things like sentiment analysis and word embeddings. This is really, I have not talked about word embeddings at all, but I kind of just wanted to point out that this is a new tool that has, I mean that promises to be very useful to the text analytics community. So, with that I think I will conclude my talk. If you have any questions, please use the home page that is given on the title page of these slides. I would be happy to respond to any questions over email. Thank you.